SD card with a G code directly into the printer, or you use it over USB or Wi-Fi. So now it's time to insert the filament into the 3D printer. Dual extruder printers are going to have dual materials with either two colors or two types of filaments. So many types of filaments are of course plastic because they melt when heated up to high temperature. The most common filament is PLA because it's easy to print with, you don't need a heated bed, and it's also very cheap. Another popular material is ABS, which is stronger plastic but a lot harder to print with. And you do need a heated bed because it has a tendency to work off the bed while printing. Also, a lot of exotics are PLA composites, which means it's a material mixed in with PLA, such as wood, which is wood dust infused in PLA, sparkle filament, which of course has sparkles infused with PLA, also glow in the dark, UV light changing, temperature changing, and also carbon fiber. Other types of plastics, like metal infused, are really abrasive, so you might want to have a ruby nozzle or hardened steel nozzle when printing those materials, because they have a tendency to slowly rub away the brass on a regular nozzle. Also, HIPs, PETG, nylon, PBU, PVA are also other types of plastics that we can use in 3D printing. And these plastics come on spools, usually around 1 kilogram, and they come in either 1.75 or 3 millimeter diameters. But it's funny because 3 millimeter filament is actually 2.85 millimeters. So most filaments come with a desiccant packet to keep the moisture out of the air and stop the filament from becoming brittle and breaking while printing. So when you're storing the filament, you should probably put it in a resealable plastic bag with some desiccants inside of it to keep it dry. Also, some filaments are not really affected by the moisture in the air that much. Like PLA is fine to keep right in the air, but materials like PVA and also TPU absorb moisture from the air and get brittle and crack, or they don't print as well as they would if the moisture was kept from getting to it. So we can feed the filament into the printer for use, and some printers print materials better than others. For instance, direct drive extruders, which pushes the filament down into the nozzle right above it with only a few inch gap in between, prints better with flexibles than Bowden feed systems. Bowden systems, the actual motor that pushes the filament on the frame of the printer, uses a long tube to feed the filament into the hot end. So there's a good foot and a half where the printer is pushing the filament up into where the filament is actually being heated up and being printed out. Also, hardened steel nozzles and ruby nozzles don't wear as fast as brass nozzles. So if you're using an abrasive filament, such as carbon fiber, you might want to think about getting a hardened nozzle. Also, heated bed printers can print much more materials than non-heated beds. Usually PLA is one of the only materials that non-heated bed printers can print. Also, printers with enclosures can print better with materials such as HIPs and ABS than open frame printers. Also, of course, dual extruder printers can print materials. Some come with one nozzle and feed in the material in one side, and then pull it out to feed in the other material. They both go into one nozzle, or others come with two nozzles with two filaments going into either of the nozzles. Also, FDM printers, they push filament through a hot nozzle, coming basically two forms: a Cartesian printer and a delta printer. Cartesian printers are the basic printers that you normally see. We print along the X, Y, and Z axis, and there's a motor for each axis. The head moves along the Z axis, the X axis, and the Y axis. Also, there are delta printers, which still uses the XYZ plane that has a circular bed and has 3 arms and 3 motors that move independently to move the nozzle around in 3D space. The basic parts of an FDM printer are the bed, the hot end, the extruder, the stepper motors, the cooling fans, the control board, the screen, and the power supply. And all these things are on every FDM 3D printer and allow it to 3D print models. And a benefit of using an FDM printer is that once the part finishes, you can pop it off the bed right away and use it right away. But that's not the case with SLA or resin printers. So for SLA pens, they use a laser to shear resin in the back and they print upside down and pull the part out of the resin as it shears layer by layer with a laser. So there's only one laser that is moved by a series of motors and mirrors to shine the laser in different points along the resin back that cures each layer. And this allows for extremely precise prints and for small objects. But the downside, of course, is that so once they're printed, you can't take off the part, use it right away. You have to let it sit for a little bit to be cleaned off and cured. Also, DLP printers are another resin printer, but they use a projector for the source of light instead of a laser. So you can start the print on the printer, and you always want to watch the first layer, which is the most important time to actually sit and watch your 3D printer. You want to make sure that on MDM printers, the part actually sticks to your bed, and the first few layers look correct. So we use glue sticks or sometimes hairspray on the bed in order to get the plastic to stick onto the build surface. Some printers use glass, some use painter's tape, some use a plastic surface like build tack, which helps parts stick correctly. Some people even use glue, such as magic glue, to get their first layer of the part to stick down correctly. And you want the first layer to not be too high, where it peels off the printer, or not too low, where it squishes into the bed. You always want the first layer to be a perfect line on the bed and stick to the bed very securely. You don't want to just wash the first layer, but the first few layers, make sure that everything's going well and the print is progressing nicely. Then you can allow the print to finish.
Test, test. Testing 1, 2. Test, test. Testing 1, 2. Test, test. Testing 1, 2. Testing 1, 2. Test, test, test. Testing 1, 2. Test, test, test. Test. Test, test, test.
This, and I'll see you guys next week. Hey everyone, welcome back to the channel. So you may have seen my first videos on video a while back. So what is printing? What is defined? You can see is a 3D model of what we call a 3D benchy. So it's a boat. We call it the benchy. And on the right is me 3D printing out that model into the physical world. So I have my model on my computer, the 3D model of that benchy, and then I'm going to lay down thin layers of plastic in succession to eventually build up that 3D model into the physical world, which I'll get into in a little bit. So as you can see here, the possibilities are literally endless. You can print so many awesome things, and it has so many awesome uses in life, as you will see throughout this presentation. So first off, let me break 3D printing up into two main groups here. There's consumer 3D printing, and there's industrial 3D printing. And in this video, I'm going to be mostly focusing on the consumer 3D printing, because that's what most of us here are looking to learn about. So on the left there, you can see a consumer 3D printer. It's called the Creality Ender 3, and it's one of the most popular consumer 3D printers because it's super cheap and is a great printer overall. On the right there, you can see an industrial 3D printer that is called a Stratasys F170. That is a huge machine. It's the size of a refrigerator pretty much, and that is super expensive, meant for industrial applications, commercial grade 3D printing. They make really great objects, but those are just way outside of our consumer range for right now. So let's get started. There are many types of 3D printing. As you can see, there are many ways to cure layers of material, as that is what 3D printing is defined as. So the first and most popular is called FDM or FFF 3D printing. The FDM stands for Fused Deposition Modeling, and the FFF is just another term for the same process, also known as Fused Filament Fabrication, but they're mostly the same thing. And this 3D printing consists of heated thermoplastics. So this is the most common type. As you may have seen,
These printers lay down these spools of plastic layer by layer. They're very common, and most of this presentation is going to be on FDM 3D printing. There's also another type of 3D printing called SLA 3D printing or stereolithography, and these 3D prints are very, very detailed, and that's because they use a laser to cure resin in a bath. There's a big tub of resin, and the laser shines on that, curing the resin layer by layer as the bed moves up and up. Also, there's a version called DLP, called Digital Light Processing, and that's another resin curing system, but it's very, very fast because it uses an LED projector to project light onto the resin to cure it. Also, there's one called MSLA, called masked stereolithography, which is very, very cheap because it uses an LCD screen to cure resin as well. So light shines up through the masked LCD screen to cure the layers of resin. So these are the 4 most used 3D printing types in the consumer 3D printing industry, but there are many, many more types of 3D printing that move into the industrial 3D printing section, so we won't get into those in this presentation. So let's get started with learning about FDM or FFF 3D printing. So as you learned before, it is the most common type of 3D printing. Material is pushed and melted through a very small nozzle and is raised layer by layer, creating our 3D model. And it is printed onto a surface using gravity and pressure. So on the right there, you can see a little diagram of FDM 3D printing. That nozzle there is pushing out this thin layer of material. You can see there it's stacked one on top of another. So it's laying on top of each other the next layer. So this material is being laid down and melted, and it fuses to the layer beneath it. And this creates a buildup of layers of material, of plastic, and that creates our 3D model. We'll get into that a little bit more later in this presentation. Also, we have SLA 3D printing. And these are very high detailed prints because they use a laser to selectively shine on resin, and that cures it layer by layer. And SLA actually prints upside down as the object is pulled from the resin. So in the diagram on the right there, you can see the bed is actually pulling the object up and it's being printed upside down. And that's because the laser is below the bed of resin and it's shining that laser all around the bath, curing one layer, and the bed moves up and it cures the next layer of resin and it moves up again until the part comes out of the resin. It's really, really cool.
Everyone hear me? Testing 1, 2.
So the next 3D printing type is called DLP, which has very, very fast print times as the entire layer is cured at a time. Also, it uses a high-power projector that shines into light-cured resin to cure each layer. Just like SLA 3D printing, it is printed upside down as the object is pulled from the resin. So in this picture here, you can see that instead of a laser being shined into the bath of resin, there is a projector that shines up and cures an entire layer at a time, which is very, very fast. But it's also not as detailed as SLA 3D printing. So MSLA 3D printing. This is a very low-cost option for resin 3D printing. It uses an LCD screen with an LED backlight that cures the resin. Also, it's printed upside down, the object is pulled from the resin, just like the other 2 resin 3D printing types. So on this image on the right-hand side, you can see this grid of LEDs that shines up through an LCD screen. So the LED backlight shines through the LCD screen, which masks out certain parts so the light can go through one part and the light cannot come through another part of the LCD screen, and that selectively shows the layer that the printer wants to cure. So the 3D printing process, this is the biggest thing to learn and know with 3D printing. This is how you start with a 3D CAD model and go through the whole process to have your 3D model in physical life in your hands. So let's get started with learning the 3D printing process and how to 3D print an object from scratch. So of course, the first thing you need is your 3D CAD models. So you need the actual thing you want to print. So there are two ways to find 3D models. The first one, which is also the easiest, is to just find models online. And there are many great websites that have so you can just download for free. There are websites like Thingiverse, My Mini Factory, Colts, and GrabCAD that host a bunch of models that you can download and 3D print, which is super cool. You can see on the picture in the bottom right-hand side, that is Thingiverse. You can see all of these cool objects that are on the popular page. So these are the most downloaded objects on the website, and there are some really fun things that you can print out. The other way to find 3D models is to make them yourself. So you can create your own CAD models or computer-aided design, and there are many CAD programs that you can use. There's Fusion 360, there's Onshape, SolidWorks, Inventor, Tinkercad, and many, many more. I also made a tutorial on how to get started with Fusion 360, which I'll link in the iCard above if you want to learn how to create your own CAD models for 3D printing. So you can see in the picture on the bottom right, that is Fusion 360. That is just a default object of a box cutter, which is pretty cool. So you can actually create from measurements if you want, or from scratch in the program, you can create your own 3D model, which then you can print and have it in physical life, which is super, super cool. So the next step is the Stl files. So you're going to export your 3D model if you use a CAD software, or if you find them online, you can just download them as an Stl file. And there's also another file type called OBJ that works the same as Stl files. So these files are made of many, many small triangles. And these are the 3D model that is easily read by the slicing software, which I'll get to in a few slides. And you can see here on the right is an image of what an Stl file would look like. You can see that little red circle around the outside, that's what your CAD model would be. But the Stl is that inner portion, which is all made of triangles. And that is the object that we're going to be able to. So you can see the more triangles you have in your Stl file, the more detailed it would be. So when you're going to export your 3D model as an Stl file, you want to have as many triangles as you're comfortable with. And of course, that will bump up the file size as well. But most 3D prints are pretty small, so you won't be able to see these triangles as much as you would think. Also, you can see this image of a controller, which is made of many, many small triangles. But if you look at it from a wider view, you can see that it looks pretty much like a controller. When you 3D print it, it'll look very, very smooth. So slicing software. This is the software that we're going to use to slice our 3D models. So there are many slicers on the market, as you can see. There's Ultimaker Cura, Simplify 3D, Slicer, Repetier Host, Prusa Slicer, Formlabs Preform, and many, many, many more. Some slicers work with many types of 3D printers, while others are specifically made printers. Like Formlabs Preform is made specifically for Formlabs 3D printers. Just like Prusa Slicers made specifically to work well with Prusa 3D printers. But some like Cura and Simplify 3D are made for many, many types of 3D printers, and you can use them on most 3D printers. So what is slicing? So slicing a 3D model, it slices a 3D model into the layers to be 3D printed. So like we said in the beginning, 3D printing is laying down these thin layers of material in succession. So our slicing software actually creates those slices of our model. This is also the place where we're going to be able to edit the settings and properties of our 3D model. So you can edit the print speed, how fast it's going to print, the infill, which is the density of material inside our 3D model, the layer height, which is the actual height of each individual layer. We can change the 3D model size and its orientation on the 3D printer. We can edit the temperature of the nozzle and the bed, and so many more settings. There's so many settings that you can print with to make your 3D model come out just like you want it to. And when we're finished slicing our 3D model, it's going to create a toolpath for our 3D printer, which I will get to in a few slides. But first, let's go over some slicing fundamentals. So I'm not going to get really in-depth. I also made a video on slicing with Cura, which I will link above. You can click that if you want to learn about slicing a little bit more in depth. But very basically, there are three major things that you should know when slicing a 3D model. You just want to think about the model's orientation when you're slicing it. On the left-hand side, these traffic cones, the cone on the right is standing upright. So it's going to print those layers one on top of each other to print up that cone. But the left traffic cone, you can see, is printed on its side, which is much harder. And that's going to need support, which is that little lattice structure you can see underneath the cone. Because printers, or FDM printers, cannot print in midair. As you can see in the middle image, it's called bridging. The printer cannot just print plastic in midair, so it just flow everywhere and go everywhere. It has to actually print on top of something, right? So if we printed this cone on the side, we need to add this support that is printed under the overhang area of the cone, which then extends the print time. It may leave some residue on the print, and it's basically just not the best way to 3D print. You want to print your object in an orientation that makes sense and print fast. Also, the image below that you can see is putting load on a 3D print. So you have to remember your 3D printer is printing layer by layer up and up and up and up. So if you print that standing straight up, the layers are going to be horizontal to the ground or to the print bed, right? So if you push a load, it's going to crack on those layer lines, right? So you have to think about that when slicing. So it will be much better if you turn that L on its side and print the layers on another axis. So then when you press on the object on that same point, if you put a load on that same point, as you can see in the green circled image, the layer lines are not in the direction, so it won't crack or split apart on those layer lines. So as I mentioned before, there's bridging and overhangs. You don't want to print in midair because we can't do that, right? So we need to have something underneath our model to be able to print. So the first layer, you're going to print on the bed, which is fine. When you print up, you're printing layer on top of layer on top of layer. So that's fine. But you can't just print in mid-air because you get all this stringing here.
Testing. 1, 2, test, test, test. Test, test, test. Test, test, test. Test, test, test. Okay, that should be the perfect volume. I'm still getting some in and out from the audio, but I think that might be because of the processor. We may have to replace it. Test, test. Okay. Meeting will call to order.